Hi, and welcome to this full-on beginner Unity tutorial. By the end of this video, you will have made a full-on game from scratch. And to prepare, we will be going over the very basics of Unity, such as placing primitive objects, using materials, collision, physics, as well as triggers. If you are a complete beginner to Unity and you are just looking at how to begin, this video is for you. This will be a really strong start in your journey, so without further ado, let's begin by installing Unity. Here we go! So we are going to get started by going to unity.com, and under the header here, we are going to select Plans and Pricing. Now we will select Student and Hobbyist, and under Personal, I'm going to select Get Started. If you're a student, you can select the Sign Up button here, but I'm going to select Personal. Now we are going to download the Unity Hub. The Unity Hub is where we will be managing all of our Unity projects as well as the editor versions. So download it for the platform that you are on. For me, I'm going to download for Windows. So once we have downloaded the install file, we are going to open it and then agree to the terms of service, and then we are going to select Install. Once that is done, we're going to select Finish, and it will run the Unity Hub. So as soon as the Unity Hub opens, we will be prompted to install a Unity editor. So the Unity Hub is our way of organizing all of the editor versions as well as the projects that we have. So what I'm going to do is just go with the default one that it has recommended. Now, if you're watching this video years into the future, you will probably see a later version here, but that's okay, because it will probably be a long-term support version, so I'm just going to select Install Unity Editor. And it will show up in the Downloads bar right here, and this will probably take a few minutes. So after waiting an eternity, we have finally installed the editor version, but we are not done yet. We have to install the correct modules in order to get it to work with our platform and to write code. So I'm going to click over here to get rid of that window, and I'm going to select the gear icon in the install that we just installed. And I'm going to select Add Modules, and this will bring up everything that we would need in terms of builds, as well as the code editor that we are going to use. So we are going to leave Microsoft Visual Studio Community 2022 checked, and because I'm on Windows, I'm going to select Windows Build Support IL2 CPP. And with these two checked, I'm going to select Continue. And let's agree to the terms and conditions of Visual Studio 2022. And that is going to install. So this is going to open the Visual Studio installer window. So I'm going to select Continue here, and it is going to get Visual Studio ready. Once that is complete, we are going to install the correct workloads that we need to use Visual Studio within Unity. So the only one that we are going to need right now is Game Development with Unity. So let's check that. We are also going to uncheck Unity Hub because we already have Unity Hub installed. So let's uncheck that, and let's select Install. So once this is done, it will then bring up a window to sign in to Visual Studio. I'm going to skip this for now because we do not need it. I'm going to select or keep the dark color theme. You can use whatever you want, but I prefer the dark theme, and we are going to start Visual Studio. Okay, so if it worked correctly, then you should see a window that looks similar to this. And if you did, congrats, you have installed Visual Studio 2022. So I'm going to X out of this and this because we will not be needing this for a little while. So now we are going to create our first project. So to create a new project, we are going to go over to the Projects tab over here, and we are going to select New Project. Now there are a few options to choose from. One thing to take note though is that we are using the editor version that we installed, and for this tutorial we are going to stick with 3D Core for our project template. Over here we could select a project name. Let's go with First Project, because this is your first project. Congrats! Now, the last thing that you have to do is pick a file location and select Create Project. Welcome to the Unity Editor. This is what you will see whenever you create a new project. And as you can see, there are a whole bunch of windows here. And the two that we are going to start out with are the hierarchy and the scene view. The hierarchy is the list of all of the objects that you have in a given scene, and the scene view is the visualization of all of those objects. So there are currently 2 objects in our default scene that we got when we started the project. We have the main camera, so I'm going to left click on this camera icon. So this is our main camera, and this is now being selected in the hierarchy and in the scene view. We also have our directional light, which is right here. So this is currently what is lighting up the scene. So let's put a few things into the scene. The easiest way that we could start out is by putting down primitive objects. Now, what are primitive objects? Those are very simple 3D objects that we can very quickly put into our scene. So what I did was click on this plus button here and then hover over 3D object, and now we can see all of our primitive 3D objects. So we have a cube, a sphere, capsule, cylinder, plane, and quad. I'm going to start out with a cube. So let's left click to place in a cube. So it now puts a cube into the hierarchy as well as into the scene. So I'm going to left click away from it just to keep its default name, cube. So now we have our cube. I'm going to use the mouse scroll wheel to zoom in a little bit. One other way to navigate around your scene is by holding down right click, and you can drag your mouse to look around. And while holding right click, you can hold WASD to fly around in the scene. Great. So let's left click on this cube and let's take a look at its properties. You can view its properties in this window here, the inspector window. And every single object that you have in a scene has a transform. The transform shows its position, its rotation, and its scale. The transform is a component of this given object, and the inspector shows all of the components that this object has. We will go through all of these components in just a second. So in the transform, we can modify its position, rotation, and scale, both in the transform component here and in the scene. Let's use these arrows here to move the cube around. So I'm going to drag the cube up a little bit, and that modifies the number here on the y-axis for the position. So we can also modify it here just by holding on to the y there and then dragging. We can move it up and down. We can also assign a set number to it, such as 1. We could also do that for the rotation just by dragging this around as well as the scale. There we go. So I'm going to undo that. Now, another way to manipulate the transform of an object is over here on the left-hand side of the scene window. We have the move tool, the rotate tool, the scale tool, the rect tool, and we have the transform tool. The transform tool is all of the other tools at the same time, except for the rect tool. The rect tool is another way to modify the position and the scale of an object, but this is mostly used for 2D objects, so we are going to ignore this one for now. The scale tool allows us to scale the object on any axis or all 3. The rotate tool does a pretty similar thing, but for rotation. And the move tool is for moving it around on any axis or 2 of them. So we have moved our cube around. What if I want to reset it back to where it was originally? Well, we can go to the transform component here, select the 3 dots, and then select reset. And this will bring its position, its rotation, and its scale back to the default. Let's add in another primitive object. So I'm going to go over to the plus button here, hover over 3D object, and I'm going to select a plane. Now, a plane is a very thin object. Actually, we could say that it has a thickness of 0, and we cannot see it from underneath. So treat a plane as like a ground. So I showed you the transform component of our cube here. The transform component also exists on our plane, and every other object that we have in the scene. Every single object will have, at the very least, a transform. Actually, one thing that we can put into our scene is, if we click on this, an empty object. And this is an object that only has a transform component. Those will be helpful later on. So I'm actually going to delete this empty game object and go back to our cube. So the next two components here work hand in hand. We have the mesh filter and the mesh renderer. This allows us to actually see the cube here. So the mesh filter takes in a mesh, and we have our default meshes here, so I can even change it to a cylinder here, but I'm going to keep it as a cube. The mesh renderer allows us to actually see the mesh, so if I were to uncheck this, the mesh will go away and leave us with this green bounding box, which is our collider, and I will get to that in a little bit. The plane here also has a mesh filter and mesh renderer, and it is using the plane mesh. So that is mesh filter and mesh renderer in a nutshell. So we have successfully put in a cube and a plane into our scene. Fantastic, but I think we are missing a little bit of vibrance. Let's add some color. So what we need to do is add a material of a set color to each of these objects. And to do that, we need to create two materials in our project window. The project window is down here at the very bottom, and this contains all of the files that we have for our Unity project. In assets here, we currently have one folder, and that is the scenes folder. And if we were to go into that, we could see our sample scene, which is right here in the scene view. So if I were to go back to assets, I want to make a folder for my materials. So to do that, I'm going to right click and I'm going to create a folder. Let's call this folder Materials. And now let's go into the folder by double clicking. Now I'm going to right click, I'm going to hover over Create, and go all the way down to the middle and select Material. Now let's make this green. So let's make the plane green for ground. So we are going to select the albedo color here. We're going to left click, and we are going to pick a green color. So I'm going to drag this circle all the way to the top right to give it maximum saturation, and let's move this circle somewhere over here. That's a pretty good value. So I'm going to X out of this, and what I'm going to do is I'm going to left click on my material and I'm going to drag it over to the plane to give it the green color. There we go. So now I'm going to make another one for our cube. I'm going to right click, hover over Create, and then create a new material. Let's make this one orange. So we're going to do the same thing as we did with the green material, except for orange. So once again, I am going to select our box here, and let's make this orange. So I'm going to drag this up a little bit. Let's bring the saturation all the way to the top, and let's see if we could find a good orange. Okay, that works pretty good. Let's X out of this, and let's drag the material over to our cube. All right, so we could zoom out, and we could see that the ground, or the plane, is now green, and the cube is orange. Fantastic. So we are going to continue by learning how to actually play our scene. So right now, we are in the scene window, but we haven't actually tried playing our game yet. The game is not in play mode. So what we want to do to play the game is to select the triangle button here called Play, and when we click on that, we will be brought over to the game window. Now, the game window is what we see when we play the game. Now, as you can see, the view changed. So where is this view coming from? Well, if we go back to the scene here, we could see that there is a main camera within the scene. And if I were to go over to it, we could see that the main camera is right here and is projecting the same view that we see in the game scene. Fantastic. So we can now see what the camera sees by hitting play, and we could play our game. But as you can see, we really don't have anything in the game to play except for looking at this wonderful orange cube and amazing green ground. But if we want it to be even more wonderful and amazing, let's actually have something going on within the game. So I'm going to click play again to stop playing, and we are going to now start talking about physics, rigid bodies, and colliders. So let's select our orange cube here, and let's take a look at the inspector and see what's in it. We have a box collider that is attached to it as a component. Now, a box collider is a type of collider, and colliders deal with collision within the game. Now, we can actually visualize this box collider by zooming in, and if you see this faint green outline around the cube, you can see that that is the collider. Now, we can adjust this outline by going over here to the center and the size. So let's say I want to drag the center on the x-axis. As you can see in the scene window, we are able to do that. And we can also adjust the size. Now that's great, but one thing to note is that colliders really don't do anything on their own. Let me explain. Let's say we want the cube to fall down onto the plane. To do that, we need to give it a rigid body. So I'm going to click on Add Component here, and let's type in rigid, and this is going to show rigid body. Let's hit Enter there, and this will give a rigid body. Now, the rigid body doesn't have an icon or an outline that you could see, but with the component on it, this now has physics. And as you can see, the Use Gravity checkbox is checked. Now, let's drag the cube a little bit higher up, and let's hit play and see what happens. Be sure to save, and let's hit play. So as you can see, the cube used physics and gravity to fall down onto the plane. Woohoo! Alright, so let's uncheck play, and let's talk about a few of the properties in this rigid body. So we have mass, drag, and angular drag. Think of the mass as the amount of influence that the cube has, or the amount of force required to get the cube to move. Let's actually duplicate this cube by hitting Control D on Windows, and this will create a new cube in the hierarchy right here. And let's drag it over to the side here. And let's actually bring both cubes down because we're going to make these cubes collide with each other. So both of these cubes have rigid bodies, but on this cube here, let's make the mass something a lot larger, like 100. And let's make the cube a little bit larger. So I hit the R key there as a shortcut for the scale tool, but you could just select the scale tool here, and I'm going to make it a little bit bigger, and I'm going to hit W to select the move tool here, and I'm going to drag it up a little bit. Now, let's actually make a new material for this larger cube, just so that we have different colors on them. So let's go to our materials folder here, and I'm going to right-click, hover over Create, and then select Material, and let's give it a nice blue material. And in the albedo map here, let's select a nice blue color. There we go. So now I'm going to drag the material onto the cube, just like we've done for all of the other objects. Okay, fantastic. So now we can see that this cube has a mass of 100 for our rigid body, and the orange cube has a mass of 1. So here's how I'm going to demonstrate the difference in mass. So what I'm going to do is drag this cube up a little bit, and I'm going to uncheck Use Gravity. So this cube will no longer be influenced by the force of gravity, which means that it will not be pulled down. Now let's go to the orange cube here, and we will keep gravity on it. Let's drag it up and right above the blue cube right here. So let's hit play. Well, actually, first, let's move the camera into a good view. So I'm going to drag the camera up a little bit, and maybe even towards the cubes. and I'm going to angle it down. The E key is the shortcut for the rotate tool, by the way. So let's just get that into a good view. And actually, while we're here, let's go back to the plane and make it a little bit bigger. So I selected the R key to scale it. Let's just make it a little bit bigger. There we go. Okay, so now let's hit play. And what you see is the orange cube forcing the blue cube down by the force of gravity. Now, that happens pretty slowly. The orange cube still influenced the blue cube, but it did happen pretty slowly because the orange cube has a much lower mass than the blue cube. Let's switch it up. Let's give the orange cube a mass of 1,000, which is now 10 times the mass of the blue cube. Now when I hit play, the orange cube heavily influences the blue cube because of the difference in mass. Now, one way to make the blue cube stop moving due to physics altogether is to make it kinematic. So if I were to select is kinematic here and I press play, what will end up happening is when the orange cube falls onto the blue cube, nothing will happen because the blue cube's rigid body is now kinematic. So two other things that I'm going to go over really quickly is drag and angular drag. So think of the term drag from physics. It essentially acts as the opposite force to any motion or angular motion that is happening to the cube. So we just learned the very basics of colliders and rigid bodies. Now, while giving gravity to cubes and making them fall is pretty awesome, let's make things a little bit more interesting. So envision this. Let's say that we have our ground like this, and let's say that we also have a ramp like this. And on top of that, let's create a little rolling ball that goes down the ramp. Now what we want it to do is, when this rolling ball enters this cube, we are going to run some code. What we need to do in order to accomplish this is to have something called a trigger. Pardon my bad mouse handwriting. But we are going to have the ball roll down the ramp and then enter this area and run some code when it does. Okay, let's go back to Unity and see how we can do this. Here we go. So we are going to start fresh by removing these two cubes. So in the hierarchy over here, I'm going to left click on the orange cube and then shift left click to also select the blue cube here. And I'm going to hit the delete button to delete both of them. So now what I'm going to do is I'm going to hit the plus button right here. I'm going to hover over 3D object and I'm going to select a sphere. And this will be the ball that rolls down the ramp that we are going to make right now. Let's make another cube. And what I'm going to do is hit the R key to use the scaling tool. And I'm going to make it larger on the x-axis and maybe a little bit larger on the y-axis. I'm going to hit W to use the move tool. And let's see where we are in the scene here. So it's floating pretty high, so I'm going to move it down a little bit. Let's also move our rolling ball down. And here we go. Let's actually center this on the z-axis. So over here on the transform component, I'm going to go over to the z-axis here, and I'm going to hit 0 to move it back. I see that I have somehow named this cube R, so I'm going to name it ramp. There we go. So now that we have done that, actually, I'm also going to center it on the x-axis by hitting 0 there. Let's go to our sphere, and let's also center it. So I'm going to hit 0 and 0 on both the x and the z-axis. Let's go to our ramp and hit the E key to enable rotation. And let's rotate it on the z-axis here so that it looks like a ramp. We can see that the back there is poking out a little bit. So let's move it down. Now that we have rotated it, we could see that the arrows for moving it down, or for moving it in general, have changed. So the arrows are relative to the rotation of the ramp. So let's look at these two dropdowns here. We have local and global here. If I were to select global, we can see that it has changed back. And no matter how much I rotate it, we can see that it always sticks to the global world axis. I'm going to undo that. So I'm going to keep it at global for now so that I can move it down. There we go. Let's move it back, or let's bring this back to local, just in case we need it in the future. Okay, so we have our ramp. Let's go to our sphere, and let's move it towards the top of the ramp here. Okay, let's assign a material to each of these. Let's make the ramp orange, just like we did in that little drawing, and let's make our sphere blue. There we go. Let's make one last cube. I'm going to create a cube here. Let's reset its transform. So this is just an easy way to bring everything to 0, 0, 0, and then 1 for the scale. I'm going to select the 3 buttons here, and I'm going to hit reset. And let's move it over here. This right here is going to be our trigger. So I'm going to name this trigger. And while we're here, while we're naming things, let's also rename the sphere. So I'm going to rename this roller ball. There we go. Okay, so nothing will happen when we hit play. So what we have to do is add a rigid body to our roller ball. Okay, so we're going to add the rigid body. Okay, so let's hit play and see what happens. Well, no, actually, let's move the camera into a good position. So we can see the preview here for the main camera. Let's move this. Actually, let's move the X over to 0. And then let's move it down on the Y a little bit. And then let's bring it a little bit closer. There we go. Okay. Okay, so now when we hit play, we can see that the sphere, or the roller ball that we created, rolls down the ramp and it collides with our trigger. Now, what we want to happen is for the roller ball to actually go inside the trigger zone, not to collide with it, because think of this as the zone that the ball will enter that will make us run some code. To do that, we have to make our box collider on the trigger a trigger. So there is a checkbox here that shows is trigger. So now that it is a trigger when I hit play, when the ball rolls down the ramp, it'll go right through our cube. And that is exactly what we want. Let's do one last thing. So our cube is now a trigger. And what I'm going to do, just to indicate that it is a trigger, I'm going to create a new material. I'm going to right-click in our materials folder, create a new material, and let's just call this trigger material. And over here in the albedo here, I'm going to left-click, and let's just make it red, and let's bring the alpha, which is the transparency, down to about half. Okay, and now let's put this on our trigger here. Okay, so now we can see that the cube, or the trigger, is red, but we don't have the transparency on it that we set on our albedo. So what we have to do is set the rendering mode from opaque to transparent. There we go. Actually, let's make it a little bit more transparent so that we can just barely see it. Okay, perfect. And let's actually make it a little bit larger, or a little bit wider, and maybe a little bit thinner. So as soon as our roller ball passes through this zone, it will execute some code that we are going to write very quickly. Now, eventually what's going to happen is we are going to disable the mesh renderer here so that it becomes pretty much fully invisible, but it'll still run the code that we want when the roller ball goes through it. But for now, just for testing purposes, we're going to keep the mesh renderer. Okay, now, on to the fun part. we're going to write the code that executes whenever the ball rolls through the trigger zone. Let's go back to Assets here, and we are going to make a new folder. So I'm going to right-click, hover over Create, and select Folder here, and I'm going to write Scripts. This is where all of our C# scripts will reside. I'm going to right-click on the folder, hover over Create, and then select C# script. And I'm going to call this Trigger Zone. Now, it is compiling code for us, as you can see in the bottom right, as well as the middle here with the window. That'll take just a few seconds. But once that is done, we will be able to edit the code, as well as put the code wherever we want. Let's start by putting the script onto our trigger zone. So I'm going to left-click on Trigger here, and I'm going to drag Trigger Zone over here, and it will plop it down as a component. Now, this code does not do anything yet because we haven't done anything. Let's fix that. I'm going to click on Assets over on the top left, and I'm going to select Open C# Project. And this will open up Visual Studio. Okay, so when you open up Visual Studio for the first time, it might do a little bit of loading here. It might allow you to access the firewall, which I'm going to select Allow there. And once that is done, it should bring us to Visual Studio. Here we go. All right. Welcome to Visual Studio and welcome to C#. If you're not familiar with how the basics of C# run with Unity, every script that you create has two methods to start out. We have void start and we have void update. Void start is the method where whatever code you put in here gets run at the very beginning whenever you hit play. Update runs every single frame, once per frame. For our trigger to run code when it gets entered, we actually don't need any of this at the moment. So I'm going to delete all of this. I'm also going to delete the first two lines here because we don't need them. Okay, what do we need to do? We need to type private void on trigger enter. Now, when I type this, you can see that Visual Studio has some recommendations for us, and on trigger enter is exactly what we need here. So as soon as you see this on trigger enter, we can hit tab to complete it. And this here is exactly what we need. We have on trigger enter, and then it passes in the other collider. Let me explain how this works. Whenever something enters the trigger zone of whatever the script is attached to, it will run the code that we put in here. Now, it also passes in something called collider other. This is the collider of the other object that enters the trigger zone. So let's see this in action. I'm going to print other.name. There we go. So what this little line of code does is it will actually print to the console the name of the thing that entered the trigger of our trigger zone. So let's test this out. I'm going to hit save. Well, I'm going to hit Control S to save. One way that you can save your script is by going to File and then selecting Save All or any of these save options here. But Control S is another way to do that. I'm going to minimize this, and this will prompt it to compile. Sometimes it compiles it in the background. In this case, that is what it did. So let's confirm that our trigger zone script is on our trigger here, and let's hit play and see what happens. Okay, so I'm going to hit pause here. So this will pause our game. As you can see, the ball's not rolling anymore. Something just happened, and you might have not noticed it, but in the bottom left-hand corner here, you can see that there is now some text, and it says roller ball. Now, to access all of the print statements that we get, we are going to go to the console window. So the console window is right next to our project window here. I'm going to left-click on console, and this is the console window. This shows all of the things that get printed out. So right here, we have our first ever print statement. We have roller ball. Now, roller ball is the name of the sphere that we have right here. So it successfully printed out the name of roller ball when it went through our trigger, which is exactly what we are looking for. That is fantastic. We have now made it so that whenever something enters a trigger zone, it will then run code, and it will run whatever code that we want. Let's test out one more thing. Okay, so let's go and uncheck play here, and let's play around with this just a little bit more. Let's have some fun. So what if we want it so that whenever the roller ball enters the trigger zone, it teleports the ball back to the beginning, and it just proceeds to do an endless loop. That sounds kind of fun. Let's make it happen. So the first thing that we need to do is we need to note the current position of the ball. So this is our position here, 1.766, 2.393. Let's actually make this a little easier to remember. So I'm going to, let's see, I'm going to make this 2 on the X, and on the Y, let's see, I'm going to make this 2.5. There we go. Those are some pretty easy numbers, 2 and 2.5. Okay, let's go back to our script, and let's go to project here, and let's go to our trigger zone script and double left click. Okay, so we have the other object here. We do not want that suggestion. So here's what we want to do. We want to say other dot transform dot position equals new vector 3, and let's, nope, we don't want that. So we are passing in the coordinates of what we want it to teleport back to. Let's pass in the coordinates that we just remembered. Okay, so let's say 2, 2.5, and 0. Now we get an error when we type in 2.5. That is because we're trying to pass in something called a double, and we want to pass in a float instead. So to fix that, we're just going to put an F there. So whenever there's something that has a decimal, you want to put an F at the end to indicate that it is a float. Okay, so let's get rid of our print statement here. And before returning to Unity, let's really quickly summarize the code that we wrote. Let's start from the beginning. So we have public class trigger zone. This is the name of the class of the script that we attach to our trigger. On trigger enter here is the name of the method that is going to run the code that is inside of it whenever something enters the trigger zone. And we can see that by seeing the collider other parameter that gets passed in whenever this method runs. Other here refers to the other object that enters the trigger zone. This line right here, other.transform.position equals new vector 3, and then the coordinates, this is the line of code that allows us to teleport the ball back to its original position. So other refers to the collider other. So this is the collider of the rolling ball that has entered the trigger zone. What we then do is we access the transform of the roller ball. This is the same transform that you see as a component on the roller ball. And then in that transform, we then grab the position. So now that we have access to the position, we now assign it to something new. And what we pass in is something called a vector 3. And a vector 3 allows us to pass in 3 values. In this case, it'll be the X, the Y, and the Z. And remember, for decimals, you want to make it so that it has an F at the end of it. Okay, so that is our code in a nutshell. With that in mind, let's return to Unity and see what this code does. So now you can see that it's compiling. Okay, so our ball's position is 2, 2.5, and 0, which is exactly what we put in our script when it enters the trigger zone. Let's hit play and see what happens. It's rolling down. All right, we have successfully created an endless loop. We could even call this perpetual motion, if that existed. Yay! Up to this point, we have learned about collision, physics and rigid bodies, and interacting with triggers. In this chapter, we are going to learn how to roll our ball around using WASD or the arrow keys. So here is our ball, and whenever we hit either the W key or the upwards arrow, the ball will move forward. Whenever we hold the A key or the left arrow, the ball will roll to the left. And same thing for the D key or the right arrow, and the ball will roll to the right. And when we hold on to the S key or the down arrow, the ball will roll backwards. So let's hop into Unity and let's get started. So we are going to begin by writing the code that will allow us to roll the ball around in the scene. So we are going to create a new script. So let's right-click in the scripts folder. We will hover over Create and left-click on C# script. And let's call this one Roller Ball. Once that script is created, we are now going to left-click on our ball, and we are going to drag the roller ball script into the inspector for it, which makes it a component of it. So, before we open up the script in Visual Studio, what do we want to do? Well, whenever we hold WASD, we want to apply force to the rigid body in the direction that we want it to. So let's open up our script by double-clicking on the rollerball script, and this will open it up in Visual Studio. So what we have to do, as I mentioned, is grab the rigid body component from the ball. So the way that we do that is first we are going to create a variable. Now, a variable is something that holds data, and in this case, we want to create a rigid body variable. So I'm going to type rigid body, and then I'm going to say RB. Now, rigid body is the type of variable, and in this case, it is a rigid body, and this is the name of our variable, RB. Now, something else that I want to do is make it private. So I'm going to type private here, and making it private means that it will only be accessible to the code that we write within this class. So in the start method here, which is called at the very first frame of the game, we want to assign this rigid body variable to the rigid body of the ball. So we are going to do that by saying RB equals get component rigid body. We already have the auto completion here, so I'm going to hit tab, and we now have the line that does that. So now our rigid body now stores the rigid body that is on the ball. Okay, so now what we want to do is take this rigid body and apply force to it. So let's go over to the update method here. And remember, this is the method that is called every single frame. So this is the method that we want if we want to continuously apply force. So how do we get the input from the player? Well, the simplest way to do it is by getting a horizontal axis and a vertical axis. So we're going to do that by typing float horizontal equals input.getAxis, and then we will pass in a string horizontal. Okay? So what this does is it calls input, and then it calls getAxis, which returns the value of the virtual axis identified by axis name. Let's clear this up just a little bit by going to Unity's documentation. So Unity's documentation can be found through whatever browser you're using, and let's say I were to type Unity docs get axis. This should show us the docs for input.getAxis. So I'm going to click on this, and let's read a little bit about the docs for getAxis. So it returns the value of the virtual axis identified by axis name. Aha, so here's some important info. The value will be in the range -1 to 1 for keyboard and joystick input devices. Now, let's break this down a little bit. So if I were to hit the A key, in this case for horizontal, the A key is what moves the player to the left. That will give us a -1. Whereas the D key we'll move the player to the right, which will give us a value of 1. Let's say I'm hitting either 0 of those keys or both of those keys at the same time, then it will give us 0. So let's actually see what some of the documentation's code here shows. So we have float rotation equals input.getAxis horizontal. So it seems like we are using it correctly. And we also have an input.getAxis vertical, which you will see right now. So now what we're going to do is type in float vertical equals input.getAxis vertical. There we go. So what this does is gives us two floats. It gives us a horizontal float and it gives us a vertical float. And this stores the value of the keyboard input, WASD, or the arrow keys. And floats are just a data type for numbers with a decimal. It's slightly more complicated than that, but that is the basic understanding that you need to know. So what we're going to do now is take this input, convert it into a direction, and then we will add the force based on the direction that we put in. So let's make a new line. Let's actually make two new lines just to separate it a little bit. So remember that a direction can be put into a vector 3. So I'm going to type vector 3, and I'm going to say direction equals new. So we are making a new vector 3, and we're going to be putting in the horizontal and the vertical input. So I'm going to say new. I'm going to say horizontal, and then 0.0f, and I'm going to say vertical. Okay, so what does this do? We pass in the horizontal as the x value, so left and right. We pass 0.0f as the y value, which makes sense because we don't want the ball to be rolling up and down when we hit the keys. And the vertical is for the z-axis, or forward and backwards. So this isn't enough just yet. The last thing that we need to do is then apply the force to it. So we have rb.velocity, which is a suggestion, but we're not going to go with that. We are going to say rb.addForce. Okay, so it is suggesting that we pass in direction. That is actually correct. So I'm going to hit tab to add that in. So we have rb.addForce, and it passes in a direction. Alrighty, so with that code written, let's clean this code up just a little bit, and then we'll return to Unity after. So let's go here to line 13 and just delete that line because it's an empty line. And once again, let's get rid of lines 1 and 2 because we do not need them. Now remember to hit save by hitting Control S, and let's return to Unity. And it will compile. Okay, let's hit play and see what happens. Okay, so I'm going to hit play. And what happens is the ball will start rolling down, but if I hit WASD, then we are able to roll the ball around. Yay! And if I were to hit the arrow keys, the same thing will happen. So I am hitting and holding down on the arrow keys on my keyboard, and it is accomplishing the same thing as WASD. Now, let's see what happens when I hold down A and D at the same time. The ball will stay in the same place. For the most part, the ball already had some momentum going on. And then same thing for W and S. The ball is mostly staying in the same spot, but remember the ball already had some momentum at the very beginning. Perfect. So this is looking very good, and if we were to roll it into the trigger zone, it will still bring the ball back to where it started. So we've added the ability for the ball to roll around, and that is fantastic. However, there is one improvement that we can make to it. So if I were to hit play again, we will notice that while we are able to make the ball roll around, we can't really control the speed that it's rolling around at. If we hold it down for too long, we will notice that the ball starts going really fast and it will just fall into the void once it goes off the edge of the ground. What do we want to do if we want to make the ball roll a little bit slower? So let's uncheck play here and let's return to our rollerball script. What we want to do is specify the speed in which we want the ball to roll at. We are going to do this by creating another variable called speed. So let's type in private float speed. Now we can give it a default value, and let's start with 3. Okay, so now that we have our speed and we have set the speed to 3, what we can now do is down here multiply our direction by the speed. Now we just assigned our speed to a default value of 3, which means that it is multiplying our direction by a factor of 3. So now that I think about it, we might actually want to make this value less than 1 so that it makes the ball roll a little bit slower. So let's actually change this to 0.3, and remember to put the F at the end so that it knows that it is a float. And let's save this, and let's see what happens. So I'm going to save and then return to Unity. And let's do one more thing. Let's actually disable this ramp here and disable the trigger zone, just so that we aren't accidentally rolling into it. And let's move the ball over just a little bit. So we will move the ball over here, and then we'll move it a little bit closer to the ground. Let's also move the camera and move it into a better spot so that we can see the ball rolling around more easily. So I moved the camera up, and I'm just going to rotate it down just a little bit. Let's switch the rotation drop down here to global so that we can move the camera along the z-axis globally. And let's change it to about here. Okay, let's hit play and see what happens. So now when we roll the ball does roll a little bit more slowly. So now that we have made the functionality to roll the ball around using input, let's make something that will make future development a lot easier. Let's enter the world of respawn points. So do you remember previously in the tutorial when we had this ramp here, and we had the ball start at the top of the ramp, and then we had our trigger zone down here, and then whenever the ball would go into the trigger zone, the ball would go back here? And remember how we had a hard-coded vector 3 that had the actual coordinates of right here for whenever the ball goes back? Now, that got the job done at that time, but what if we want to move that coordinate system around? Well, that is where respawn points come into play. We can create a respawn point that allows us to have an empty game object, which we could just drag around the scene, and whenever the ball has to teleport back to it, it would go wherever the respawn point is. This will make future development so much easier when we are making our own level and we are making it so that the ball has to go back to a certain respawn point. And whenever we change up the level, all we have to do is drag around the respawn point instead of having to type in another hard-coded number such as 10, 5, 7.5, or something like that. This will allow us to iterate a lot quicker. So let's hop into Unity and let's begin. All right, let's move on. So right now, what we have is a trigger zone that we have disabled, but I'm going to re-enable it. So remember how when we set up this trigger zone, whenever the ball rolls into it, it teleports the ball back to a position that we specified. Now, that is great, but there is actually an easier way to do this. We can actually create an empty game object, place it anywhere that we want within our scene, and then have the ball teleport back to wherever that object is. This will make our game development a lot easier when we are testing things out and moving it around. So let me show you what I mean. We are going to make a new empty game object by going over to the hierarchy here, and then hitting the plus button, and then hitting create empty. Now, this is going to be a fully empty game object that only has a transform as a component. It has no other components, which means that it doesn't have a mesh, doesn't have a collider, doesn't have a rigid body. It only contains the transform, so where it is, its rotation, as well as its scale. Let's rename this to respawn point. There we go. And let's see where it is in the scene. So it's kind of out of the way, so I'm going to select the 3 dots here, and I'm going to hit resets to bring it back to 0, 0, 0. So let's see where it is now. Okay, let's actually move it up just a little bit. Let's say 1, and there we go. So if I were to click on respawn point here in the hierarchy, we can see that it is right over here. Now, let's have it be so that our ball teleports back to this point whenever it hits a trigger zone. Okay, so let's do that. Let's go back to our two scripts, rollerball and trigger zone here. So I'm going to click on, let's say, rollerball first. So now that we are in rollerball, what we have to do is grab a reference to this point. So here's how we do that. We're going to say private transform, and then we will say respawn point. There we go. Cool. So we are going to save that, and let's actually condense these variables here. So we now have a respawn point variable that we can then assign to the transform that is in the scene. But let me show you one thing. So I'm going to go back into the scene, and it will compile. So when we click on our rollerball here, it will bring up the inspector. What we want to do is actually drag the respawn point transform into the inspector of our rollerball. And there's a really easy way to do this. So going back to the script, all we have to do is next to the private here, we put in a pair of square brackets, and then we say serialize field. So what serialize field does is it exposes this variable to the inspector. So now when I hit save and go back to Unity and click on our ball, we now see that we have the respawn point as a variable that is exposed in the inspector. Now we could do this with a large range of variable types, but in this case, this is a transform. So now all we have to do is drag the respawn point transform, or the game object, into the respawn point transform variable, and it will save the transform of our respawn point. Fantastic. So we have now done everything that we need to do with the rollerball. Now let's go to our trigger zone script, and let's change it so that it actually teleports the player back to the respawn point, as opposed to the hard-coded coordinates that we put in. So let's go back to the trigger zone here by double-clicking on it. So now what we have to do is instead of saying other.transform position equals new vector 3, let's actually grab the player script from the object that enters it. Let's make a new line, and let's say roller ball player equals other dot game object dot get component, and then we will pass in a roller ball. So I have just auto completed that. So what this does is it goes to the other collider, it goes up a level, and it goes to the game object, and then once we're at the game object level, it goes down and it grabs the rollerball component from our game object. So we are now getting the rollerball component from every single object that enters the trigger zone. Now, this is great, but the player might not be the only object that enters the trigger zone. So what we have to do is actually make it so that this code only runs when the player, specifically, enters the trigger zone and nothing else. We can accomplish this using something called tags. We can assign a tag to any game object that's in our scene, and then we can check and see if the object other is of the tag that we want. So this is our way to filter and actually see what object is which and run our code based on if it's the right object or not. This is actually pretty easy. So we could say if other dot compare tag. Now, here's where we put in our tag, and we can make this whatever we want. So I'm going to call our tag player. And now what we could do is actually run our code based on this if statement here. Let's do something called fail fast And let's actually say that if it is not of tag player, we want it to just stop running the code here because there's no point in running this code. I'm going to put an exclamation mark here. So if the tag is not the player, which is what that exclamation mark means, we are going to return. And for those who don't know, return just means that the method just ends right here and it doesn't move on to the rest of the code. So running through this, it takes other, and if other is not of the player tag, we are going to stop right here. So we are now checking for the tag, but we haven't assigned the tag to the player. But we will do that as soon as we are done writing this code. So now the last thing that we have to do is change this line here, where we change the position of the other object, or the player, to the position that we want it. Now, originally, we teleported it back to a hard-coded vector3, but in this case, we want to bring it back to the position of the transform that we assigned within our rollerball script. Let's go back to the rollerball script and see what that variable is. So we have a private transform respawn point. Now, because the variable is private, it is not accessible by anything else outside of this class. That means that Trigger Zone cannot access this variable right here. So I'll show you what I mean. If I were to go back to Trigger Zone and make this new line, so I would say transform player respawn point equals player dot respawn point. So as you can see, we now have an error because it is inaccessible due to its protection level. So it's not actually able to get this variable right here, respawn point. So what we want to do is make an accessor for this variable. So down here, what we're going to do is create a public transform for our respawn point. And then within this public variable, we're going to get our private variable. We are going to type public transform, and then let's just rename it the same thing, except we will capitalize the respawn point variable. So I will say respawn point. So now we're going to put in curly braces here. And what we're going to do is use something called a getter. So here is how we're going to do this. We have tab to accept here because of Visual Studio's suggestions, but let's just type it in manually. Get. So now we're going to type in something called a lambda, and a lambda basically gives us a one-line method. So I'm going to hit equals and then right arrow, and then I'm going to say respawn point and then semicolon. And we don't need a setter here. That's not something that we have to go over in this tutorial. So what does this do? This allows us to access our respawn point variable from other scripts. And the reason why we are doing it this way is to help with encapsulation. So now going back to our trigger zone script, what we could do is just change this to a capital R, and this will allow us to get the public respawn point variable. Fantastic. So let's save both of these scripts. And let's move on to the next point of trigger zone. So now all we have to do is copy our player respawn point here, and then take our new vector3 that we wrote previously and replace it with player respawn point dot position. There we go. Now we can actually condense this a little bit more. So let's actually do this. Let's say player.respawn point. So let's take this, let's copy it, and let's replace player respawn point with our player.respawn point. And now we can delete this line right here, and let's condense these. So now we have our other.transform.position. So we are assigning the position to the player that has entered, and we are assigning it to the player's respawn point position. Okay, So we are done writing code for now. So let's go back to Unity. And there is one last thing that we have to do. And that is to take our roller ball and assign a player tag to it so that it can then compare the player tag within our script. So how do we do that? Right underneath the name here, we have tag, and it is currently untagged. And upon clicking this drop down here, we can see that there are a few default tags that we can work with. Thankfully for us, there is already a player tag. But let's really quickly go through the tag creation process just to see what it looks like. So I would select add tag here, and we have an empty list for our custom tags. So let's click on the plus button here, and we can actually add a new tag here. So I will say new tag. Now remember, this is just to show you how to make a new tag. So we're not actually going to use this permanently, but I'm going to hit save. So now we have our own custom tag. So now when I go back to the rollerball script, I now see the new tag over here. But we actually don't need this. So I'm going to go back to add tag, and I'm going to select new tag, and I'm going to delete it. And that's because when I go back to my rollerball, I could then just select the player tag here, which is a default tag that just comes with the editor by default. And I'm going to select player. Great. So we now have our player as a tag of rollerball. So now, when I hit play, what will happen is when the ball enters the trigger zone, the ball will go back to the respawn point here. So let's see this in action. So let's first make sure that the main camera is in a good spot. I'm actually going to move the camera back a little bit, just to make sure that it works. And let's actually do one last thing. The respawn point is currently invisible, but let's actually give it a small object just to show it where it is. So what I'm going to do is right-click on respawn point, hover over create 3D object, and I'm going to give it, let's say, another sphere. Now, this will make the sphere a child object of our respawn point. And I will explain what that means in just a second. So I'm going to name this marker just to show where the respawn point is. And let's make our marker a little bit smaller. So let's select the scale tool here, and let's just make it pretty small, but not so small that you can't see it. And now, when I move respawn point, it will move both respawn point and marker. So that is one of the benefits of marker being a child object of respawn point. So let's move respawn point over here. And there we go. Cool. So when the ball enters the trigger zone, it will go back to this respawn point. Let's hit play and see what happens. So I'm going to roll the ball into it. And there we go. The ball is now being teleported back to the respawn point. Now, as you can see, when the ball teleports back, it kind of does a jerking motion. And that's because our respawn point marker actually has a collider on it. So let's actually unplay, and let's get rid of the sphere collider on our marker because we don't need it. Okay, now let's hit play again, and let's roll into the trigger point. There we go. So we can now move our respawn point to any spot that we want, and the ball will teleport back to it. And the best part about this is that we can actually move our respawn point in real time, and the ball will instantly teleport back to wherever the respawn point is when the ball has to get teleported back. So be sure that you have the respawn point selected, and we can actually move this to any space that we want. So we can even move it back here. And I have unchecked play, but I'm going to check it again. And when we move the ball into the trigger zone, it will go back to the respawn point that we have set. This even works in game. So if I were to go back to the scene here and then move the trigger point, let's say right here, really close to the trigger zone, and then I were to move it there, the ball will teleport back to here as opposed to here. So it will always know where the location of our respawn point is, which is fantastic, and it makes game development and testing a lot easier. So now that we have finished configuring our respawn point, we have almost all of the components that we need to actually start building our game. Now, you may notice that a couple of things in this level is a bit different, and that is because Unity actually crashed pretty soon after I finished my previous recording. So I had to set up everything again, so if it looks slightly different, that's why, just in case you were wondering. But yeah, so the next thing that we're going to do is set up our level that the ball is going to roll around in. So let's make an environment, and we will set up a bunch of walls that the ball will bounce off of if it rolls into them. So let's create a new empty game object, and this is going to serve as the container for our environment. So I'm going to call this environment. There we go. And this is going to have nothing in it. It's going to be an empty game object, and it is going to contain all of the assets that will be in our environment. So let's move the position back to 0, 0, 0, so that the position of the children is also relative to the position of the world. And the next thing that we want to do is put down a cube. So I'm going to right-click on Environment, hover over 3D Object, and select Cube. Now, by right-clicking on Environment, we create our cube immediately as a child of the environment, as opposed to having to drag it in after. So I'm going to call this Wall, and let's see what we have. So the wall spawns in at 0, 0, 0. Let's move it up a little bit, and let's see, let's move it over here. Now, let's assign a color to our wall. Let's make it orange, because that's a color that we haven't used yet. And let's figure out where our walls are going to be for the game. So here's what I'm going to do. I'm actually going to zoom out and take a screenshot of this, and we will bring this into our drawing app and actually draw out a little drawing of our walls before we put them down. So I have our drawing app open here, and I have our screenshot. So let's start drawing out the level that we're going to make for the roller ball. Let's have it so that the ball starts here. So I'll draw some walls here, and let's make it so that it goes up a little bit, and then let's have it loop around, and then we could have the ending be right here. So we could have the ball kind of loop around this curve here, and then it'll end. Now, this seems like a very easy level. We would just have it be so that the ball goes around and ends. Not very exciting. But remember, we have our trigger zones that we created, and whenever the ball rolls into the trigger zone, it goes back to the spawn point. So this can create for some very interesting, let's say, traps that the ball can fall into that we don't want to roll into as the player. Let's draw those, and let's make them orange, and let's see what we can do. So we can put a couple of traps around the map. So we could put one here so that the ball has to roll to the left. Let's say, since this is pretty wide, we can put a few around here. And then let's make it pretty difficult at the end. Let's put one here and then one here so that the ball has to roll in between the two to finish the level. So that means that the path of the ball, ideally, would probably be something like this. Yeah, something like that. And then the ending will be here, and we will write a very short script that does something cool when it reaches the end. Sweet. So this is our little prototype level drawing. So let's go back into Unity and let's implement this. So we are back in Unity. Now, what we want to do is align our view within the scene so that we can easily make this level. So what I'm going to do is move up a little bit by holding right click. And then I'm going to select the Y cone here, so this green cone. I'm going to click it, and then I'm going to click on the orientation cube here to bring it to orthographic view. Now this will make it a lot easier to see what our level looks like from the top down. Now it is rotated sideways, but that's okay. We could build our level sideways to what we drew. Okay, What we're going to do is take this cube here and we're going to start moving it around and duplicating it. So I'm going to move it over here and let's hit the R key to adjust the Z scale, make it a little bit bigger. Now let's drag it down here and let's duplicate it. So by selecting the wall in the hierarchy, let's hit Control D to duplicate it. Now that'll give us a new one. And let's hit the E key to enable the rotation here. And what we're going to do is just rotate it a little bit like this. What we can do actually is change the Y rotation just to be 90 so that it is perpendicular with the wall right here. Now here's a cool trick. So what I could do is use vertex snapping to make sure that it is completely flush with this wall right here. So I can hold the V key to snap the orientation to a vertex here, and I can hold left click to then snap it to the edge of this wall right here. So it is perfectly flush. So now what I'm going to do is hit Control D again to duplicate this wall, and then do the same on this side. So I'm going to zoom in a little bit with the scroll wheel. I'm going to hold V, and then hovering over this, I'm going to hold left click and move it over here so that it is snapped. Okay, let's move our trigger zone out of the way. So let's move it here. And let's also move our respawn point. Let's see, where's our respawn point? I think our directional light is in the way. There we go. So let's move the respawn point back here to the very beginning. And let's actually not remove, but let's disable the mesh renderer so that the respawn point is invisible, because that's probably not something that we would want in our game. Let's now duplicate this wall and move it over here. Let's make it a little bit smaller on the Z-axis, and let's move it over here and snap it with that cube right there. Let's duplicate it again, and then let's make it a little smaller on the Z-axis. This doesn't have to be perfect. This is just for prototyping, which is A-okay. Let's duplicate this wall now and move it over here. And let's snap it to this wall. Perfect. Duplicate it again. Snap it to this wall. There we go. Now let's duplicate this wall. Move it over here. And let's actually make this wall a bit larger. There we go. And what you'll see happens is that really this turns into a flow of moving around walls, duplicating them, and snapping them to the corners of other walls. So let's duplicate this one now, move it here, snap it to there, and let's make this one a little bit smaller, and then we will snap it here. Okay. And now let's make this one a little bigger. So then I will re-snap it. There we go. Let's duplicate this wall here. And here we go. Let's snap it here. Awesome. Let's actually make this a little bit bigger. Now we're going a little bit different than what's in the drawing, but that's totally fine. We can do whatever we want. Let's make this cube, or this wall, bigger. And move it there. And this here will be our finishing point. So what I'm going to do is duplicate this, move it over here, make it a little smaller. And this doesn't have to be perfect. Oh, one other thing that you could do is, what I just did there was I hit the F key to focus on this cube, or this wall. So if I were over here with this wall selected, and I hit the F key, then it brings me back here, which is exactly what I did there. Let's snap this to here, and let's move this up just a little bit. Once again, it doesn't have to be perfect, but what we could do is, let's actually move this back, and then let's make one more wall, and we're going to rotate this back to 0 degrees. And let's move it over here, make it a little bit smaller, and let's snap it to that wall right there. So This little outcropping here will be our finish. Perfect. Okay, so we've made our little rollerball layout. Let's go out of orthographic view and see what we have. So the walls are a little bit above the ground, but that's okay. Let's go to our environment here. Let's select every single wall by selecting the top one and then holding shift while selecting the bottom one. That will select every single wall. And what we're going to do is just lower this a little bit into the grounds there so that it actually intersects with the ground. Perfect. Something else that we could do is actually make these walls a little taller so I can move them a little bit above. And with all of them selected, I could hit the R key to scale them on the Y axis. And that will make the walls a little bit taller, if that's something that you want to do. There we go. Okay, so we have created our walls now. So there is one last thing that we need to do to our walls, and that is to rotate them in the correct direction. Let me explain. So when I hit play, you will notice that there are two things that will happen. The first thing is that the camera is rotated so that it is looking sideways compared to the front of the map that we had in the drawing. The second thing is that we will notice that by moving the ball, W makes us go this way, and S makes us go that way. And if the camera were rotated, let's say, in the direction that faces forward, the ball will make it so that W and S both go forward and backwards relative to world space. What this means is that if we were to only rotate the camera, the ball will not go in the direction that we want it to go in, based on what we had our keys in. Now, there is a way to make it so that the ball moves around in local space or relative to where the camera is looking, but we're not going to cover that in this tutorial. Instead, what I'm going to do is rotate all of these walls so that it is in the proper orientation. One kind of a hacky way that I'm going to do this is I'm going to create a new empty game object, and I'm going to call it walls. Now I'm going to move it into the environment here, and I'm going to set the position to 0, 0, 0. And here's what I'm going to do. I'm going to select the first wall, and then while holding shift, select the last wall, and then I'm going to drag all of them into the walls game object here so that they are all children of the walls game object. And now I'm going to rotate the walls game object. So by hitting E, I'm now going to rotate it to an angle of 90 degrees. And what this will do is rotate every single wall without changing the local rotation of any of the walls themselves. So now we see that things are a little bit out of place. So let's just move all of the walls, let's say right here. And then let's take our respawn point, re-enable the mesh render so that we can see it. And let's move. So we have to select the respawn point again. And let's move it back to around here because that's the respawn point of the ball. And now let's take our player and let's move it back to around the position of our respawn point. And now let's go to the sphere in the respawn point and disable the mesh render so that it is no longer visible. Great. So the last thing that we're going to do is let's now adjust the camera here, okay, so that we can see most of the level. Now, don't worry about the final camera position now, because what we're going to do very soon, actually, is make it so that the camera follows the ball around as it goes through the scene. But we will be doing that momentarily. The next thing that we are going to do is place down our traps. Now, when I say traps, I mean really just our trigger zones, and those are the things that will send our player back to our respawn point. So let's go to our trigger here, and let's actually reuse this asset here. Let's drag it over here, and let's see what we could do with this. Let's bring our scale back to 1, 1, and 1 so that it is a cube. And let's assign a new material to it. So I'm going to right-click in our materials folder. You might have been in the scripts folder, so let's go back to the materials folder. And I'm going to right-click, hover over create and create a new material. And let's just call this trap. And for now, let's just make this red. So 255 on the R and 00 on green and blue. So it's just pure red. And now let's drag it over our trigger here. And now it is a trap. So let's see what this is. So it's still called trigger. So I'm going to rename this to trap element. And here's what I'm going to do. I'm going to, in environment, create a new empty game object called traps. And this will once again have a completely default transform component. And let's move our trap element inside our traps here. Now, here is what we're going to do. So our trap is currently a cube, which is okay, but that's a little bit boring. So let's make this a little bit more exciting. Here's what we're going to do. Inside of traps, we're going to create a new empty game object. So I'm going to do create empty, and I'm going to call this trap. Now let's find out where this trap is. Okay, it is right there. And let's do this. Let's move it up a little bit. Let's move our trap element inside of trap. And you'll see where I'm going in just a moment. Let's move our trap element to 0, 0, 0. Let's get rid of the trigger zone, as well as the box collider, so that it is just a mesh. And under trap, let's put our box collider back on it. And let's also put our trigger zone component back on it. So the box collider and the trigger zone are now part of this parent called trap, and trap element just has the mesh. What that does is it allows us to have multiple meshes inside of trap without the collider and the trigger zone being bound to just the mesh, which means that I can move this trap element over here, and the collider or the trigger will be right here. So it will not move when we move our cube. We have to remember to enable isTrigger on our collider here. So there we go. So let's move our trap element back, and let's make this look a little bit better. I'm going to duplicate trap element, and let's do this. Let's rotate it by 45 degrees. There we go. And let's see what else we could do to this. So let's duplicate it again. And actually, let's do this. Let's make this one 30 degrees, and then we'll make this one 60 degrees. There we go. That's looking kind of cool. And let's do one more thing. Let's now create a cylinder. Okay. So let's hit F to focus in on that. Well, I just changed the name, so let's rename this to trap element. Let's hit F to focus in on it. Hit R to adjust the Y scale, and let's just add a little bit of a cylindrical top to it. Now let's assign the trap material to it. There we go. So now we have something that looks a little bit more interesting. And let's go back to trap and see where our collider is. So the collider is still going around one of the cubes there, but remember, it is not part of trap element, so we're good. And let's just put this a little bit deeper into the ground. There we go. So if the ball goes into this trap, it will then be brought back to the respawn point. So let's test that out. So we are going to hit play. And here we go. So when the ball rolls into it, it'll then be brought back to the respawn point. Hooray! There we go. And it's just doing it over and over again. Perfect. So what we want to do is duplicate this trap around the entire course. Now, there is one thing that we're going to want to do, and we're going to want to make this a prefab. A prefab allows us to change one of them, and it'll change all of them at the same time. It's basically like our template for our trap here. Now, I'm not going to go too far into detail, but by making this into a prefab, hopefully you'll see some of the benefits that making it a prefab will do. So here's what we're going to do. We are going to go to assets here, the assets folder, and we're going to create a new folder. And we're going to call this folder Prefabs. And we're going to take our trap here and we're going to drag it into our Prefabs folder. Now, what immediately happens is you will notice that our trap here becomes blue. So the icon here becomes blue. And in our prefabs here, we can see that we have our trap as a prefab. Now, what's really cool is that, let's say I were to duplicate this trap. So let's say I put the trap here, and then let's put another trap here. And let's say that I were to double click on this prefab here. When I double click on it, it brings us into a new view where we can actually modify the prefab for our trap. So let's say I want to give part of it a new material. So let's say I go into materials, and let's say I make the cylinder, that's too hard to notice. Let's say I make the cylinder blue, and then I save it, and then I go back to my scene here by selecting this arrow here. This brings me back to the scene. Then voila, all of the traps have their color changed, have the color of the cylinder changed. So that's one of the really powerful things of prefabs, is it allows us to modify a template and basically distribute that to all of the instances in the scene without having to change every single one at the same time. So let's go back to trap here and let's make the material red again. There we go. Perfect. And then let's go back. All right. We actually have a pretty good layout here for a prototype for a rollerball game. Let's actually duplicate our trap one more time, or two more times, and let's make it a little bit more difficult at the end. So we could make something like that. There we go. I don't even know if the player is wide enough for that, or thin enough for that. Let's actually duplicate this trap and then move it along the x-axis so that the z position is the same, just to make it look a bit neater. Now let's see if the ball is actually thin enough to go through that. So I'm going to just move the ball here. Okay, so it is just barely thin enough. Fantastic. So I'm going to move the ball back, and let's just play this and see how easy or hard this is. So I'm going to roll the ball. The ball is going. Now you'll notice that when the ball reaches here, the ball could get out of sight. And we're going to fix that by making it so that the camera can follow the ball around. Ooh, there we go. Ooh, that was close. All right, there we go. Nice. So we've reached the end. So let's go over the two final things that we have to do to this level. We have to make it so that the camera can follow the player, and we have to make it so that when the player reaches the end here, something cool happens. So let's do that. So in order to get the camera to follow the player, there are two things that theoretically we can do. Here's the first way, and this is the way that won't work, but I think it's kind of funny to show. So I'm going to show the first way. So the first way would be to make the camera a child of the ball. Now that's really easy. So all we have to do is take our main camera here and drag it into the roller ball so that it is now a child. And in the scene view, what you'll see is if I were to bring this back to pivot, now that it's over the roller ball, we can now move the roller ball. And as you can see, the camera moves along with it. So this looks like it would work in theory, but let's see what happens when we hit play. Upon hitting play, we can see that when we start moving the ball, whoa! Yeah, so when... that's so funny. So when the ball rolls around, wow, that's making me dizzy even. So when the ball rolls around, it makes it so that the camera goes along with it. And let's see what this looks like in the scene here. So let's switch back to the scene view, and we can see that the camera is going on an absolute joyride here, which is fun and kind of funny, but not exactly what we want, and not really something that one of our players would enjoy. So let's uncheck play here, and let's undo this. So I'm going to move the main camera back up here. so that it's no longer a child of the roller ball. What we're going to do is make a new script that we're going to attach to our camera. Now, the script will be pretty small, but this script is going to make it so that the camera is always at a given offset from the ball, which makes it so that the camera doesn't roll around with the ball when the ball moves. So let's go to scripts and we will create a new script. So right click, create C# script, and we will call this camera tracker. There we go. Let this compile. And once it's done compiling, we will open it up in Visual Studio. So we're in Visual Studio once again, and the first thing that we're going to do, just like last time, is get rid of these first two lines because we don't need them. And let's begin. Let's create a new transform variable where we can store our player. We are going to say private transform, and then we will call this player. Now we want to expose this to the inspector, just like we did for one of the variables in our player script. So we are going to serialize this. So square brackets and then serialize field. Going to complete that, and there we go. So that's the first thing. The second thing that we need is an offset. This is how far away the camera will be from the player at all times. So I'm going to say private vector 3, and then I will call this offset. Now we do not need to expose this to the inspector because we are going to calculate this inside the script here without needing to do anything in the inspector. So the next thing that we're going to do is just that. We are going to get our offset. So we need to subtract the player's position from the position of our camera, and that's how we get our offset. So I'm going to say offset equals transform dot position minus player dot position. And I don't know what that suggestion is, so we're just going to click out of that. So yeah, this is what we need to do to get our offset. Now, because we only need one line inside our start method, we can actually tidy this up a little bit and make this a lambda. So we are going to hit equals and then the arrow here. We're going to cut this line out, paste it on the same line as void start, and then we're going to get rid of our curly braces. And that just makes it so that it's all on one line, and it's neat and tidy. Perfect. So now the next thing that we need to do is we need to move our camera in accordance of this offset. So we're going to make sure that the offset is the same exact value every single time. So when the player rolls further away, now the offset is greater. We're going to want to move the camera so that it matches the offset. So let's do this right here. We are going to say transform dot position equals player dot position, and this suggestion by Visual Studio is correct. So player dot position plus offset. So what this will do is it'll always keep the position based on the offset. And we're done. Let's do one last tidying up, and let's also make this a lambda. So I'm going to cut this line out. I'm going to get rid of the curly braces. I'm going to hit equals and then the arrow here, and then put this line here just so that it is a one-line method and it's all neat and tidy. There we go. Perfect. So let's exit Visual Studio and let that compile. So once we're done compiling, we can now go to our main camera and drag our camera tracker as a component to our main camera. So let's drag the camera tracker down here. And now it is asking for our player transform. So let's take our player wherever it is. So rollerball. Let's actually rename rollerball to player just so that we have a good consistent name. So let's go back to main camera and we're going to drag the player into our player transform. So let's see where our camera is right now. So I'm going to select the main camera and hit F and zoom in a little bit. Now here is the camera preview. Let's zoom in just a little bit. So I'm going to just adjust the camera a little bit. Let's see where the player is. So the position on the X, let's move the position back to 0. No, let's make it 1 so that it's kind of close to the center there. And let's make the camera's X 1 as well. There we go. And let's rotate the camera down a little bit. And let's also move the camera this way and this way. We'll make it so it's a little bit closer to the ball. All right, there we go. Let's test this out and see what happens. So I'm going to hit play, and here we go. All right, so whenever the ball rolls, the camera moves with it, which is exactly what we want. Woohoo! Yeah, this is perfect. And already this is looking so much better. And wow, those two traps really come up as a surprise now because you don't see them until the very end, which makes the game a little bit more difficult. Fantastic. So the very last thing that we need to do is make it so that something neat happens at the very end here when we reach our destination. So let's do that. So what we're going to do now is create an area that basically serves as a trigger zone, except this time when the player enters it, something else will happen. So what we're going to do is create a cube, and we will put this inside the environment, but I'm just going to name it first. So I'm going to call it goal. And let's make this a child of the environment here. And let's zoom in a little bit, and we can see that it placed it in all the way down there. So we're going to move it up, and let's move it over here. And let's make it a little bit bigger. So we want it to fill this area right here. So let's make it a little bit bigger like this, and a little bit bigger like this, and just make it so that it fills in this area here. All right. So the next thing that we're going to do is let's assign it a material. Let's repurpose this trigger material here. Let's rename it to goal material. And let's make it a nice yellow. There we go. And let's assign it to our area. Now, yellow might actually not be the best color because it blends in pretty well with the ground here, which is green. So I take that back. Let's make it purple instead. Fantastic. All right. So let's click on the goal here, and we can see that there is a box collider that is not a trigger. Let's make it a trigger. And the very last thing that we want to do is now write our script that runs the code that we want it to do when the player enters it. So once again, we are going to go to scripts, and we're going to right click, hover over create, select C# script, and we are going to call this goal zone. How about that? So upon opening it up in Visual Studio, we see that we have the default script here. So once again, I'm going to remove these first two lines because we don't need them. And let's go into trigger zone here and see what we have in here. We have on trigger enter collider other, and if it's not the player, it returns. If it is the player, it runs code. Let's copy this. So we are in trigger zone right now, the trigger zone script. We're going to copy this code and bring it over to the goal zone code. Let's remove void start and void update. So I'm going to delete, and I'm going to hit Control V to paste in our code from trigger zone. And the next thing I'm going to do is remove this code here because we don't want to move the player back to the respawn point because that is the job of the trap. So let's say winning code here. Okay, so we scan and see if the other collider is the player. And if it is, we have our code here. So what do we want to have happen when the player completes the level? Well, here's what I'm thinking. Wouldn't it be really silly if we just launch the ball up really high into the sky when the player wins the level? Yeah, that would be a good way to celebrate winning the level. So here's how we do that. We're going to type other.getComponent, and we need to get the rigid body from the ball so that we can apply a force to it on the y-axis, which is up and down. So I'm going to say rigid body here, and then do empty parentheses, and then add force. So we need to pass in a vector 3 for our force. Let's do it this way. So first, I'm going to start by typing in null. Now this will give us an error, I suppose, but let's actually give us the ability to change the force in the inspector. Let's create a new vector3 variable. So we are going to expose this to the inspector. So I'm going to start off by saying serialized field with the square brackets, and I'm going to say private vector3, and then let's call it launch force. So now what I could do is, instead of putting null or whatever we were going to put in there, and I'm going to replace it with launch force. So now when we go back into Unity, we can actually configure this. Let's do one last thing just to add a nice warm touch to it. Let's add a print statement. So I'm going to say print, you win, with 3 exclamation points at the end. Now, this will not be visible in the game when you build it, but it will at least be visible in the console, which is okay for now. So I'm going to hit save and return to Unity. So now that we're back in Unity, what we want to do now is go to our goal, and we want to drag the goal zone into our goal as a component. Okay, so we have dragged it in. So now we have the launch force as our variable that we can configure. Let's make this an astronomically high value, like 10,000. Okay, there we go. So let's see if this works. I'm going to hit play, and if this works, then we are pretty much done. So let's navigate around these traps. There we go. Okay, oh wow, I did not get out of the way in time. So that's a good way to show that the trap works, at least. Okay, so here we go. Rolling around and colliding into the wall, avoiding that trap, and avoiding those traps. And here we go. Okay, are you ready? 3, 2, 1. There we go. Well, I guess I could say that it works. And if we go to the console here, it says, you win. Nice. All right. So I could say that this is a good conclusion to our player winning this level, and a good conclusion to us creating a very simple rollerball game filled with walls, traps, and something exciting to happen at the very end. Hey, we're falling down now. And we're going to fall into the void. Yay! That is the conclusion to the full-on beginner Unity tutorial. I hope you learned a lot, and I will see you in the next video. Goodbye!